chapter. We looked last time at some concept with regard to the CPS, and we said that we are using a model for the CPS architecture, or a reference model, which comprises 3 levels. We do have a device level, control enterprise level, and a cloud level. And we started by looking at the device level, which is known as a constrained edge networks, where you do have those smallest devices, okay, and it might contain many smart small devices, okay. You might find those smart devices from any device, everyday things, that might be from small sensors to an AC, coffee maker, machine, and anything everyday usage of. You can imagine any device that can be part of a smart environment, okay, and those devices are linked to another level through a gateway. And we said that these devices, which are part of the device level, they do have some constraint with the limitation of power processing, limitation in the size of memory, and limitation for, let's say, the energy or the source of energy, because they are using battery, and they solely rely on that, let's say, the battery, for instance, for being run, or the life of those devices is on the hand of the battery. And that's why we're going to see later in next chapters or next slides, mostly next chapter, inshallah. One of the attack objective of the hacker is to deplete, or to consume, to make things that will push those small devices to act, or to do some operation in order just to reduce their energy and to deplete their energy. Beside those constraints, we said those small devices, they are used, okay, because they are cheap and they can be employed in a large environment at a large scale. In terms of communication between, in this device level, in the edge network, and we mentioned the edge network, we say that because most of the computations, operations are done at this in this part of the network. That's why it is called edge network, instead of doing those tasks or operations at the level of another level, which is, let's say, for instance, server or data center devices. So it is done at that specific level. We said the communication between those devices, it is done through wireless communication, using the low power wireless communication, using ZigBee or the IP version 6 low wireless private area network, okay. And we can find other protocols. When we talk about machineries, we do have some machines. Those machines have their own protocols to communicate between each other. We said we do have the second level, which is the control enterprise level. Here, usually, this control enterprise level is connected, okay, through a gateway. There is a communication between device level and control enterprise level through the gateway, okay. And in here, you do have the internet backbone, where you do have those servers that will control and analyze and receive the data. Okay, they are considered as a backend server, where they will receive data from the device level in order just to process, analyze that data, for instance. We said in this control enterprise level, we can have some servers, for instance, that are at the same level, or we might have many levels of servers where there will be some communications and communication and link between those servers. We said that we do have, or we might have another level, not necessarily, but most of, let's say, most of the organization now, they are using the cloud level, okay, where we do have a cloud level, we do have the inter-cloud communication level, okay, and people now are storing their data on the cloud level, even the processing and the analysis of the data is left to the cloud service, and it is done at the cloud level instead of being done at the control enterprise level. Previously, it is used at this level. Every data or the gathered data is sent to the control enterprise level, where that data is analyzed. Then the proper action or decision is taken and sent back to that physical or device level. Now, as we mentioned, we do have now all that computation, the analysis of the data is done at the cloud level. Okay, and we said inside the cloud level, we might have the different layers of architecture exists within the cloud level. Okay, you do have, like, imagine that in the cloud level you do have many tasks or many functions, and each function is done by some specific organization or by a third part, which is another company, okay, or subcontractors that are responsible for doing some specific task within the cloud. Okay, and we said that within the cloud level, we do have what is known as multi-tenancy. Multi-tenancy, where something that is inherent to the cloud computer. That means it is normal thing that you can find in the cloud level, where you do have many organizations are renting, okay, or are using the service of the cloud. That means when you do have a multi-tenant, if you go to the application database, it is shared by many tenants, many organizations. This is where we do have the multi-tenant. As a single tenant, where you do have each organization, okay, these are represented by organization, they do have their own application and database. Okay, you can see here. However, in this multi-tenant, everyone is using the same application, the same database, and the data is mixed up inside that cloud. This is what is known as multi-tenant. And we said that some organizations, they cannot afford to have their own cloud infrastructure or rent on their own one part of the cloud. So they tend to have a cheap cloud service by sharing the cloud service with other organizations or other users. Okay, of course, as we mentioned, this will open many threats and many security flaws when we do have that shared data, which we're going to see later, inshallah. In terms of the information flow, okay, now how that the data flow from one part to another part. In our reference model, humans are taking or having two different roles. Okay, if you go back to our device level, we do have his human. These are representing humans. Beside the devices, we have sensors, for instance, and we do have humans that are in the device level. So, as the role of those humans, they can be subject to data collection by smart devices, or they will receive some services. Okay, that means you might be subject to data collection. And for instance, if you pick up a smart health device that is implemented on some human or a patient, okay, that means we are using that device to get the data from that person, from that patient. That means that's why we say that person is acting or having a role of being subject. That means the data is collected from this guy, from this person. Or he will be a receiver. He will receive some services. Okay, he will receive some services from other devices. That means he will be a recipient. Okay, that means that guy is having two roles, subject or recipient. At the same, you can have the same, or he might be both. We can have a person can be both subject and the recipient at the same time. as I mentioned, for the healthcare, for instance, this guy has a health device that will control the level of blood sugar, for instance. Okay, that means the level of the blood sugar of that patient is taken from that person. Okay, it is the subject. Then once that data is analyzed by, let's say, the same device, if it sees that, for instance, the level of the sugar has decreased or has increased, it will automatically trigger something that will inject in the body of that patient some medicine, for instance. That means we can find that the same person is at the same time a subject and a recipient. They will receive some services from those smart devices. Okay, Shabab? So this is with regard to the human roles within our model. Another thing, when we talk about the flows of information, we might have an inter-level communication, and we can have an intra-level communication. When you talk about the inter-level flow of information, we mean by the data will flow upstream. What do you mean by upstream? That means it goes from the device level to the control level to the cloud level. Okay, where it is more processed and analyzed. Okay, the inter-level, when we talk about the inter-level, we are talking about the communication between different levels, between the different levels, between the device level, which is, let's say, this is the lowest level. Then we said it is upstream. It goes to the next highest level, which is the control enterprise level. Then it goes to more highest level, which is the cloud level, if that level exists within an organization. This type of communication, the flow of the data, is known as an inter-level between each level. Okay, Shabab? For the intra-level, that communication data, that means we are talking about the flow of information within the same level. When we say that I do have a sensor communicating with the sensor, communicating with the human, communicating with another device within the same level, we are talking about the intra-level communication. Okay, if we talk about, we go to control enterprise level, when we do have one server that is communicating with another server. Okay, because they are at the same level, we talk about the intra-level communication. You go to the cloud level, when we talk about the cloud communicating with another cloud, when we do have the inter-cloud communication, we are talking about the intra-level, at the same level. Those components participating, or subject participating in the flow communication, they belong to the same level. So we say that we do have an intra-level communication data. Clear, Shabab?
Yes, clear.
Okay, and sometimes, as we mentioned, for the cloud level, we might have, for instance, inter-cloud communication, where you will have each cloud, okay, will do some specific task. Okay, maybe one will store the data, the other one will have powers, and it does have powerful servers where they do, let's say, processing and operations. And here, management, okay, cloud, that is responsible for managing the data, ordering the data, managing the data of different organizations, because it is multi-tenancy cloud. So you might find the inter-cloud communication, because each part is, each cloud has its own specific task to be done. Okay, not necessarily we should have that inter-cloud, but we can find some services that relies on the inter-cloud communication. Okay, where each one has some specific task to be done at some specific sites. Okay, Shabab? So this is with regard to the different communication of the information flow, how the data or the information flow goes from one level to another level. in terms of the CPS evolution, okay, in terms of CPS evolution, here we are talking about that the CPS is not totally a new things, okay, that has just arisen in the last few years, but it has some history, some past, okay, in terms of the devices that were used. Okay, in the past there was the RFID, okay, where you do have some devices that have some technology embedded in them, and you can control them and you can track them, okay, using wired or stationary network, okay, and they have some identifiers for data collection. When you do have, for instance, some items, you do have a shoe, you do have the T-shirt or whatever, and it does have a tag, an RFID tag, that will identify that item, specific item. Okay, it is considered as a sample or an example of a CPS device. Then, okay, after the RFID, you do have what is known as WSN, wireless sensor network, okay, where you do have standard embedded platform, some platform or some infrastructures that have wireless communication on it, okay, and the network is using wireless, mobile, receiving real-time data, and that data is taken or it is collected from sensor devices. Okay, then we do have, let's say, this is the trend of the new technology of the devices, where you do have ICT moves inside the devices. That means you do have the computing part, the cyber part, now is included in the device themselves. Those devices will have their proper CPU, proper memory, processing, and all the stuff. As a network, you might have exchange to, these are different types of network, exchange to exchange network, or you might have machine-to-machine networks, when you do have communication between machine without any interaction of human being, okay, and the type of data that is collected is considered, it is known as big data. So this is, like what we are saying, is something that is related to the evolution of the CPS devices. Okay, as we mentioned, they do have their root from RFID, moving to the WSN, moving to ICT, and so on, from identifiers to sensory to big data. These are the trend of the new technology, where now we are talking about big data. We are generating big data, we are collecting big data from those CPS devices, okay, using different types of network. In terms of security privacy threats in existing in the CPS, okay, we go back to our model. Okay, when we talk about, we pick up, if we go to the device level, we do have, for instance, many security threats are related to RFID. What type of those security threats? You do have an eavesdropping, okay, you do have a spoofing, and any kind of duplication. That means physical duplication, where you do find someone who will duplicate the same device. You do have, for instance, an access point. They will do create another access point, another sensor, or you will have some counterfeiting of the tags. Now, for the RFID, with regard to, we talk about the privacy. Here as an example, or let's say a threat that is related to RFID. I don't know, I think Benetton. Do you know Benetton, Ishadar?
What is it, doctor?
Sells clothes.
Oh, yeah.
Okay, you will find they do have their shops in many many malls. You do find the shop that is called Benetton that sells clothes for kids, and so on. I think in 2000, they wanted to keep track of their product by implementing an RFID for each item they sell. And that RFID tag, okay, they decided to be active even if that item is sold to the customer. Because usually when you do have a tag, for instance, the tag should be removed. Okay, once it is, yes, it is okay, understandable that the tag will remain on the item as long as that item is within, let's say, the shop, okay, to keep track of, let's say, the number of items that have been sold and so on. But normally once that item is sold, the tag should be removed. Okay, but that Benetton decided to keep the track, to keep those tags or those RFID tags in the garment that they are going to sell to customers. Okay, and it has created a big campaign against Benetton because people or the customers were concerned about their privacy. They didn't want to be tracked. Let's say, for instance, you bought some anything from Benetton, and it does have the RFID, and that RFID will keep track of your location, for instance. And people, they don't want to be tracked. This is with regard to the privacy. This is something that is private to people. So after a big campaign by from people, okay, they changed their mind and they removed those RFID from the tag, and they no longer use the RFID after the items are sold to the customer. So just show you that sometimes, okay, the RFID threat, or the existence of the RFID threat the privacy of people, for instance. At the device level, as we mentioned, we might have eavesdropping and spoofing. There's someone who is listening to the communication. We said that we do have an intra-level communication. We do have the communication between those devices existing at the device level. You might find someone who is eavesdropping to the communication. They might also use spoofing. They might pretend. They will pretend to be XYZ sensor, and they will send some data to another sensor, to the gateway, okay, pretending to be from a genuine sensor belonging to the device level. Okay, or you will find someone who will fake a device and put his own device within that network. If he manages to access that infrastructure and put his own device, okay, to pretend to be part of the network, and he will receive everything that goes or that is exchanged at that device level. Okay, this is one of the challenge or security threat that is related to the device level. We might have some threats at the control level. When you say control level, we do have here, we are talking about using for specifically wireless communication. You do have some sensors and actuators, okay? They are connected through gateways, okay? That we mentioned in our model, okay? This is the gateway, okay? And the data that is collected is sent to the control enterprise level through the gateway, okay? Here, by using such ways of communication, okay, it creates some types of challenge with regard to the security and privacy. Specifically, as we mentioned, for instance, you might find someone who is accessing the devices, the sensors, and spoofing the sensors and sending fake data or wrong data to the gateway that will be sent to the control level, okay? And those control level, based on that data, they will take action, okay? Sometimes the data itself is sensitive, okay? Let's say we are talking about some types of production, like a nuclear plant, and they don't want the data that is exchanged by the devices within the nuclear plant to be spoofed or to be someone will get a hold of that data, and that data is sent to the control level for further processing. Okay, that means you need to keep that data secret. Now, that's why we say that at this level, the control or enterprise level, we might have many challenges related to the security. Okay, we might have issue that is related to protecting the data. As we mentioned, you are sending data of a nuclear plant. You need to prevent someone from getting the data. You need to have some protection that will prevent the leak of that data. Sometimes we do have what is known as auditing and provenance. We talk about provenance is from where the data comes. Okay, provenance is like when we talk about the metadata. Does anyone has an idea about the word metadata? Yes,
it's the data about the data. For example,
right.
a picture, when it was taken, what's the device, the date about it.
Yes, very good. Okay, this is the metadata. So the provenance is related to the metadata history, for instance. When you say, for instance, I will send the data, and that data will hold the information about which device and at which location the device that has, say, the identity of the location itself, about the data from where it has been taken. And consider we go back to our nuclear plant example. Suppose now the nuclear plant is hidden, it is a secret, has a secret location, and that some machine within the nuclear plant are sending some data to for instance, to the control level. Okay, to the control level. Now, when we do have that control level, okay, on its own, the control level will send the data to the cloud. Okay, now the cloud, as we mentioned, in some organization, they don't have enough resources to process the data or to analyze the data, so they will rely to the cloud. Okay, and the data that is sent to the cloud, we might have someone who is sniffing to the communication between the control level and the cloud level. This is one of the issues related to the cloud level, where someone is sniffing or sitting as a man in the middle and reading the data. Okay, that means the data is leaked when it is sent to the cloud level. We said also sometimes you are relying to the cloud level service, but you don't want to be located. You don't want to those people who are within the cloud level to see your location. This is what we said. This is an issue with regard to the auditing and the provenance. You need to keep your location secret, hidden, and you don't want the data that you are sending will hold such information. Okay, some issues with regard to the information processing at the cloud level. Okay, when we said the information processing, as we mentioned, we do have many people are accessing the same infrastructure, which is the cloud level. Okay, they are using the same services provided by that cloud. That means there is an issue about, let's say, the confidentiality of the data. And more on top of that, what you can find third party accessing the cloud. Here we talk about under foreign jurisdiction. That means in some country, there are some regulations that will dictate to any cloud service provider the data that is stored there should be accessed, or they should allow a government agency, for instance, to access the data, to see the data. Okay, that means here we talk about third party, unauthorized third party. Why? Because when you sign the contract, for instance, with the cloud service provider, okay, they didn't mention that your data might be or will be accessed by another third party, because they are under some government rules, okay, and by law they have to let that government agency to access the data. And this is one of the issues that can be found at the cloud level. Okay, Shabab? The other part, now as a countermeasure, we need to have more granular policy on the storage and distribution of data. We talk about granular, that means we need to have some detailed policies, and we have to specify exactly how the data will move, how the data is stored, how the data is flowing from one device to another device. We have to be to specify in details what will be inside, for instance, what will be inside as a policy that will run inside each level, okay, whether device level or cloud or the enterprise level, control enterprise level. This is one of terms with regard to the policies. The other countermeasure that we can use is what is known as using the hard cryptography. Hard cryptography means using what is known here, we talk about homomorphic encryption. That means you will access the data, okay, of course you will encrypt the data, okay, and the data that is sent from control enterprise level, for instance, to the cloud level, it will be encrypted, okay, and the people the responsible for the cloud level, they will be able to work on that data even if it is encrypted. We call this homomorphic encryption. That means you will be able to do some calculations on encrypted information, okay, without decrypting the data, because you need to keep your data secret because of the issues of that we have mentioned previously. So you will encrypt data. You want to be provided by some services, but at the same time you want to keep your data secret. So you will use what is known as something known as homomorphic encryption, which allows at the same time the data is encrypted, and at the other hand, the cloud level will be able to process such encrypted data at the same time. They don't need to decrypt the data and get the plain data in plain text to process it. While the data is encrypted, they will process it, then they will send you the response, or they will send you the result. And when you receive the result, you will decrypt the data because you are the owner of the data. You have the keys for decrypting the data. So you will decrypt the data and get the result of such process or service that have been provided by the cloud level. Okay, and we're going to inshallah next session. We will see a video about the homomorphic encryption, how the homomorphic encryption is